today's lesson, we're going to learn how to calculate percent composition in different chemical compounds. It's very easy once you see the different types of problems you can run into. If you can calculate the percentage of a mark on a test, for example, and you know a little bit about chemistry, it's pretty much the same thing. The only difference here is we're trying to figure out the percent composition or the breakdown by percent of different elements in a compound. So we're not looking at grades here, we're looking at how much of each element is in a particular compound. So let's go over a couple of terms first before we start into some problems. So what actually is percent composition when you hear that definition? So if a question asks you to find percent composition, what it wants you to find the mass percent values for every single element in a compound. So express the mass as a percent and list it for each element that's there. So if you had an example C8H18, that's called octane, we would need a percentage for carbon and we would need a percentage for hydrogen, and we'll figure out how to calculate that in a minute. But if you listed its percent composition, here we've got a percentage for carbon, and here we've got a percentage for hydrogen. So that's the percent composition of octane. 84.1% of it is carbon, and 15.9% of it is hydrogen. When you hear the term mass percent, it's basically just saying when you want to calculate percentage, you've got to use masses. So you take the mass of the element in a compound and you're going to express it as a percentage. How do you calculate that? You're going to look at this formula here. It's very easy to use. So you figure out what's the mass of your element that you're interested in finding the percentage of. You divide it by the total mass of whatever that compound is, and then you multiply by 100%. So it's expressed in a percentage. Why we can do this or how we can do this goes back to a law. This is one way back from Unit 1 when we were talking about atomic theory. It's called the law of definite proportions. This goes back to the fact that when you're looking at chemical compounds, the elements that are there are always present in the same proportions by mass. So if you figure out the percent composition of a compound, it can help you identify it if you are trying to figure out what a sample is made up of. Knowing the percent composition is really the first step to figuring out what that compound is. In the next lesson, you'll learn how to actually figure out a chemical formula, and we use percent composition data to do that. But before we get there, we have to learn what are the different ways you could actually calculate percent by mass. So we're just going to walk through 3 questions for our lesson so you can see what some different scenarios are if you're running into percent composition problems. So let's take a look at problem 1. A compound with a mass of 48.72 grams is found to contain 32.69 grams of zinc and 16.03 grams of sulfur. What is the percent composition of the compound? So let's take a look at the numbers that we have. Here, the first number is telling us the total mass of the compound. It says a compound has this mass. So we're going to call this our mass, and we're going to write down total beside it for reference. So 48.72 grams. Then we've got a couple of elements. We've got a mass of zinc. So we're going to list that here, 32.69 grams. And we've got a mass of sulfur. So they've already given us some information about which elements are present in our compound. They're asking us to find the percent composition of the compound. So if they're asking us to find that, that means we need the percent of zinc and we need the percent of sulfur to answer this question. So it doesn't matter which ones you start off with. Since zinc is listed first, let's go with that. So percent of zinc, we said from our previous formula, we need to take the mass of our element and divide it by the total. So here the mass of our element is 32.69 grams, and you divide it by the total. So 48.72 grams, and we're going to multiply by 100. When you do that, you should get somewhere around 67.097%. And then don't forget about your significant digits here. That applies to these problems as well. All of the values in the question all have 4 significant digits. So here, make sure your final answer is rounded to the correct number of significant digits. Once you have the percentage of one element, you can repeat and do the same thing for the others. But in this question, since I only have 2 elements, I can use a little shortcut. I know percent has to equal to 100. So if I'm trying to find out the percentage of sulfur, here I can use a trick and do 100 minus my percent of zinc and get there faster. So if I was looking at, well, what's my percentage of sulfur? I could do 100 minus the percent of zinc, and that's going to give me 32.90. If you didn't remember this little trick and did the same thing, you can do the same as taking the mass, but instead of putting the mass of zinc on the top, you take the mass of your sulfur and divide by the total, and you'll get the same number. So that's one way you can calculate percent composition. You might be given some general masses, and then you go ahead and calculate it. Here's another problem where we're also going to find out percent composition, but this time it's a little bit different. So here we've got a compound called cinnamon aldehyde. Yes, that's the molecule that gives the flavor of cinnamon, and we have its formula this time. We want to find out its percent composition. So if you take a look at this question, it's a little bit different than before because this time we don't have any numbers. The last time we had some values. So what if you actually don't have any numbers, but you know what the formula is? Because of the law of definite proportions, it doesn't matter what size of your sample is here. If you know the formula, the breakdown of each element by its percentage is going to be the exact same. So if we want to find out the percent of carbon, hydrogen, and oxygen here, it doesn't matter what sample size we use. But there's one that works well for us that we've learned about before, is molar mass. So why don't you take a minute just for some practice, pause the video, and our total mass is going to be the molar mass of our sample. So see if you can find out what the molar mass of 9 carbons, 8 hydrogens, and 1 oxygen is. When you're ready to check, unpause, and we'll keep solving. All right, so hopefully you found somewhere around 132.17 grams. All of my numbers are coming from our general periodic table. This is going to be our total mass. Now, if we want to find out the percent of each element, not a problem. We're still going to go back to molar masses, so keep your periodic table handy. If we want to find out the percentage for carbon, we can just take the molar mass of carbon. We're going to divide it by our total molar mass, which we just calculated, and multiply by 100%. Now, we don't just want to write down the mass of one carbon here. We have to go and look at our formula. How many carbons are there? See that number there? There are 9 of them. So our molar mass of 1 mole of carbon, or 1 atom of carbon, is 12.01, but there are 9 of them. So 9 times 12.01, that'll give us 108.09, and our units are grams per mole. We divide that by our total and multiply by 100. Here, we don't have any values for significant digits, so keep 2 decimal places, and that's usually a little bit more accurate. And we've got 81.78% here. So this is the percent of carbon. So why don't you try one out? Let's see if you can find out the percentage of hydrogen, doing it the same way we just did for carbon. So pause the video, give it a shot, and when you're ready to check, we'll go through the answer. All right, so same idea, we'll set it up. You want the molar mass of all the hydrogens divided by the molar mass of the whole sample, and we're going to multiply that by 100. So when we look here, there are 8 hydrogens. So 8 times 1.01, its molar mass will be 8.08 grams per mole. Our total is our molar mass. And I just realized I missed the grams per mole up here, so let's add that in. 132.17 grams per mole. Multiply that by 100, and you'll get 6.11%. For the last element, you can do the same process, find its molar mass, divide by the total, or we can use that same shortcut that we did previously. We know the total for percentage is always equal to 100, and now that we have 2 out of our 3 percentages, we can just subtract them from that 100, and we should be able to get our last percentage for oxygen. So 100 minus 81.78 minus 6.11, and you should be left with 12.11%. So that's another way you can calculate percent composition. What if you know the formula but don't have a mass? Just use the molar masses. Use the total molar mass of the entire compound for your total, and then use the molar mass and the number of atoms to figure out how much mass you have for each element. Finally, we've got one more problem. There are some exceptions with percent composition that aren't broken down by elements. Sometimes we want to look at specific compounds. Now, if you remember back when we learned about nomenclature, we learned about hydrates. Hydrates have water in them, and sometimes it's helpful to know what percentage of water is in those hydrates. So some percent composition problems might ask you to do something like this with a hydrate. So not much different, but just a little bit of a different approach. So first, for some practice, pause the video and see if you can write down the formula for copper 2 sulfate pentahydrate. If you need to have a look at your periodic table and ion list, go for it. All right, let's make sure we check your formula work here. Copper 2 sulfate is CuSO4, and the pentahydrate, make sure we've got 5 water molecules. Okay, in this question, we're asking for the percentage of water. So how much of this entire sample is water? So here we're not finding the percent composition of the whole thing. We could do that if we wanted. We just want to know, well, what's the percentage of water? Here there's no values given, no experimental data, so we're just going to use molar mass again. So we need to find out what is the mass of 5 molecules of water. We're going to use its molar mass. Our total mass will be the mass of the entire hydrate. So what's the mass of 1 mole of copper 2 sulfate pentahydrate? And then we need to multiply that by 100. So pause the video again, see if you can find out the molar mass of water. Don't forget to multiply it by 5. Then find the total molar mass of the entire compound. And then you do the calculation to see what the percentage is. So try that out. So let's take a look at what you've got. If we have 5 water molecules, we know that each water molecule has a molar mass of 18.02 grams per mole. We can put that in. Our total molar mass, when you've calculated it, should be 249.72 grams per mole. And don't forget to multiply by 100. So when we do that, we get 90.1 grams per mole divided by 249.72 grams per mole, all times 100. And here again, keep 2 places in with no significant digits. You should get about 36.08%. So that means out of all of the samples of copper 2 sulfate pentahydrate, 36% of it approximately um, is due to water. So there are a few different ways you can calculate percent composition. So hopefully that helps understand that concept.